Hi everyone, welcome to Deepu's Chemistry. We are continuing our discussion on how to answer previous year CSIR question papers from chemical sciences, and this is our third part based on the basic aspects of organic chemistry like conformations, stereochemistry and aromaticity. So in this class also we are going to discuss some of the questions which are asked. Now look at the first question that we are going to discuss. Which one of the following statements is true for the following transformation? Looking at this transformation, we can say that it is a nucleophilic addition, something like that, because here you are given a Grignard reagent, and Grignard reagent will provide the carbon nucleophile which will attack this carbonyl group to get the alcohol, right? So these are your two products given here, and you need to select which is the right answer, because this right answer is based on which one is the major product and which product it is, whether it is CRAM or anti-CRAM. So first of all, we can do the easiest thing. We can decide whether it is CRAM or anti-CRAM. We know in this compound this product obeys CRAM's rule, because you have the CRAM's rule with chelation model present here due to the chelation of this magnesium with this carbonyl oxygen. It will be following CRAM's rule, because the intermediate will be stabilized by this chelation between oxygen and magnesium. So it will be CRAM's product. So option A or C is the right answer. Now looking at which one is the right answer, A or B, which is the major product. Now this carbon nucleophile will attack this carbonyl group from the plane which is opposite to that of this bulky PHCH2 group. So that means this PHCH2 and the incoming allyl group, this is allyl group, will be opposite to each other, you can say. Now which one follows these two conditions? Here you need to find this incoming allyl group and phenyl opposite with methyl and CHO is also, or methyl or OH group is opposite. Here methyl and OH is opposite, but here look at this PHCH2 group is lying here, and this allyl group is also on the same plane. It's above. So this is not your product. If you want to have the methyl and OH on the opposite side, you need to have this PHCH2 and this allyl group on the opposite as well. So B is not your product, so A will be the product. What happens in A here? Look at A. Me and OH are given in same plane, so we can have this PHCH2 and the allyl group on the same plane. So that is given here. So option A is the right answer. A is the major product and it is a CRAM's product. Okay. So now coming to the next question. Among the following, the compound which has the lowest energy barrier for the cis trans isomerization. It's one of the easiest question. In all these compounds you have a C double bond C between two rings, and you need to cleave this double bond in such a way that both the species will be aromatic. Now looking at the first one, this is sp3 hybridized carbon, so you can't have any aromaticity, so you neglect option A. Now coming to option B, if this carbon is positive, it will be anti-aromatic due to 4 pi electrons. Now coming to option C, if you have a negative charge in this 5-membered carbon, it will be aromatic, and if you have a positive in this carbon, it will be also aromatic. It's tropylium cation. So option C is your right answer. Okay, so option C is right. Now next question. Coming to the next question, the IUPAC is the name of the given compound. It's one of the easiest question, where you need to find the configuration around the double bonded carbon, because when you are looking at the compound, the names which is given, see it is given as 2,4-diene-1,6 diol in all the cases. So you don't need to worry about the OH group and the double bond. What you need to find first of all is that what is the difference between these two is that in one case you have chlorine in 3 position and the other one chlorine in 4th position. So that means you need to select the carbon chain and you need to have a branches with the minimum number. So we can say option A or B is the right answer, where chlorine will be at the 3rd position. So 1, 2, 3. Now, so this is your numbering system from left to right. Now, what about this C double bond C? It is having Z configuration, because the highest priority groups are on the same side, it's below. So it will be 2Z. So the right answer will be option B, 2Z4E. Okay, so That's the answer, option B. Now, next question. The major product formed in the following reaction is. Here, it is a nucleophilic addition, or it's an addition elimination mechanism given by alkyl halides or aryl halides. Here, the OMe group is getting replaced to chlorine. Chlorine will be replaced by OMe group. That's the reaction. So look at the first option. In the first option is given that OMe group is going to this carbon. How is it possible? Because this carbon, OMe is an electron rich site. So in this carbon is also electron rich. So it will be repulsion. So option A cannot be your answer. Now the next one, look at this. This chlorine is getting replaced by the OMe group, which is possible because if you have OMe attacking here, you can have the double bond shifted to nitrogen. It's more electronegative. It is possible. So option B can be the answer. Now look at option C. In option C it is given that NaOMe, OMe minus attacks this carbon to leave chlorine. And it is also possible because it is in conjugation with two nitrogen, two electron withdrawing group. Here this carbon is attached to only one electron withdrawing group, but here it is attached to two electron withdrawing group, which can stabilize the molecule. So out of this, you can say the major product will be given by the replacement of this chlorine with OMe group. It's the addition elimination mechanism. 229C is your right answer. Now, next question based on conformation. For acylation with acetic anhydride or triethylamine and oxidation with the chromium trioxide of the transensis alcohols A and B, the correct statement is. Which one is your correct answer? See, these two compounds are cyclohexane systems, and in which one position is occupied by tertiary butyl group. So tertiary butyl group is locked in equatorial position, as we all know, and this one is trans alcohol, and this one is cis alcohol. And we can show the Newman projection formula of these two compounds like this, and in which what is happening here is that here it is trans alcohol, and look at the first question which is given here. Which one undergoes acylation faster? During acylation, the OH is converted to OCOCH3, which will increases the repulsion or interaction between the 1,3 diaxial interaction, and it will happen if OH is axial. And you need to find in which case OH is axial, and in that case the acetylation will be slower. And if these OH and tertiary butyl group are cis to each other, you can say the OH will be axial and it will not give acylation much faster. So out of A and B, we can say option A will give you acylation faster due to reduced 1,3 diaxial interaction. Now coming to oxidation, during oxidation this OH is converted to double bond O, which is decreasing the van der Waals repulsive forces. So it will happen when the OH is axial. OH is axial, which will due to the steric acceleration. So we can say this one B. So OH group axial will give you oxidation faster. OH group equatorial will give you acetylation faster. So we can say option C is your right answer, in which A undergoes acylation faster than B, and whereas B undergoes oxidation faster than A. So that is your answer, option C. Now look at the next question. The two benzylic hydrogens HA and HB in 1 and 2 are. It's very simple question. You have a plane here passing through this molecule above and below same, so it will be an anisotropy, but here it is diastereotopic because there is no plane. So it will be option B, diastereotopic in 2 and an anisotropy in 1. Right? Okay. Now, next one. Deuterium kinetic isotopic effect for the following reaction was found to be full. Based on this information, mechanism of the reactions. Because what is happening here is that this NMe3 group and a proton is getting eliminated, and if you replace it with the deuterium, the reaction rate becomes much faster. So that means the rate determining step or the slowest step consists of the breakage of deuterium, which is happening only in the case of E2 mechanism. E1CB is not possible because there is no electron withdrawing group. Free radical is not possible, and out of E1 and E2, E2 will be your right answer. Next question. The correct order of basicity of the following anions is, and we all know these are all phenoxide anions, and its basicity is decreased by the electron withdrawing group. Nitro group is electron withdrawing group, so we can say these are electron withdrawing groups which will decrease the basicity of the phenoxide anion, and which out of which Here nitro group is in ortho, meta, here para. And we all know nitro group will decrease the electron density very least when it is in meta position, because O minus is an ortho para director, right? So it will, the basicity of the phenoxide anion will be much less when you have NO2 in either ortho or para position. So the most basic compound will be the 2, that is meta nitrophenoxide. So 2 will be your first one. Then comes out of 1 and 3, due to the ortho effect of this, due to the ortho effect you can have acidity much decreased here. So out of 1 and 3, 1 will be least acidic. So the right answer will be 2 is most, then comes 3, then comes 1. So A is your right answer. Now, next question. The absolute configuration of the two stereogenic chiral centers of the following molecule. Here you have given a carbonyl group here. So 1, 2, 3, 4, 5. You have 5 and 6 chiral centers. And this carbon, we all know, this carbon is attached to this carbon, which has 3 carbons. This carbon is attached to this carbon, which has 1, 2, 3 carbons. Here only 1, right? So out of these two, we need to assign which one will be made, which one will have higher priority. So looking at the next one, you have the carbonyl group here. Here no carbonyl group present here. So here it will be the first priority group. Then comes this one. Then comes this one. So this will be something like this, clockwise rotation. So clockwise rotation means it will be R, but the highest priority group is on the wedge. It will be S. Okay, it will be yes. Just a minute. Okay, so it will be S around this carbon. Now coming to this carbon, we can have the carbonyl group as the first priority, then comes this ethyl group, then comes this or carbonyl group as the first priority, then comes this carbon in which here you have only 1 carbon attached to it. Here you have 2 carbon attached to it. So here it is your first priority, here it is your second priority, here it is your third priority. So something like this is going to happen. Something like this. That is anti-clockwise rotation. That is S will be expected, but lowest priority group is on the wedge. So it will be R. So it is 5S, CSIR. Okay, so this is option C is your right answer. Now next question. The correct statement about the following molecule is: it is biphenyl, which is optically active only due to the presence of chiral plane, and it's a direct question. The molecule is chiral and possesses a chiral plane. So option A. Now next question. It's a 4 statements are given regarding cis and trans decalin, which is quite direct. And you need to select which are the right answers. The cis isomer is more stable than trans isomer. Which one is more stable, cis or trans? It will be a trans, because decalin may be considered as 1,2 disubstituted cyclohexane. So in the trans form, both the cyclohexane rings are fused through equatorial, while in cis it is axial equatorial. So equatorial is more stable, so trans isomer is more stable. And which one will undergo ring flipping? Trans isomer cannot undergo ring flipping because it will give to axial conformation, which is very less stable. So cis isomer will undergo ring flip. So option B and D are your right answers. So option A, which has B and D. So 25A is your answer. Now next one is very simple. Carbon atom C3 and C4 in D ribose. You can check it out. It is R and R configuration. Okay. Now the next one, the compound that is anti-aromatic. It's very simple question. This one will be anti-aromatic because 4 pi electrons are there, 4 n system. So 4 pi electrons. Here it is 6, here it is 6. Here you can have 2, which obeys Huckel's 4n plus 2 rule. So here option A is your right answer. Now looking at the next question, the increasing order of the pKa values of the circled nitrogens in the following compounds. Here pKa value, increasing order of pKa means decreasing order of Ka or decreasing order of acidity. That's what asked here. Now coming here, this circle carbon, if you hydrogen, if you release this hydrogen as H plus, you can have a negative charge here, which will be stabilized by these 2 carbonyl groups. If you release hydrogen from here, it is stabilized by this 3 carbon system as well as cyano group, which is triple bond. So here out of 1 and 2, 2 will be more acidic and it will be having lesser Ka value, or higher 2 will be having lower pKa value and 1 will be having higher pKa. Now coming to option 3, if you release H plus from this position, what is going to happen is that you will end up with a positive charge on the sp hybridized carbon, which is not at all stable. So we can say out of 1, 2 and 3, 3 is your least acidic compound and it will be having the highest pKa value. So option A or C is your right answer, and out of option A or C we can say which one the most pKa value will be highest for 3 and it will be most less for 2 because it is highly acidic. So option C is your right answer. Okay, so option C is your right answer. Now, coming to the next compound, the decreasing order of basicity of the following compounds. Here you are given 4 compounds. Look at the first one. This nitrogen is sp3, this nitrogen is sp2, this nitrogen is also sp3, this nitrogen is sp2, and we all know sp3 nitrogens are more basic than sp2. So we can say out of this 1 and 3 will be more basic when compared to 2 and 4. And out of 1 and 3, due to the presence of 3 nitrogen here and this, if you replace this remove this H plus, you have a nitrogen with a negative charge which can be stabilized by this C double bond and C single bond and as well. But here you have only one stabilization effect with the C double bond. So out of this 3 and 1, 3 will be most basic. So 3, then comes which one will have the 3 as the major one. So 3, that is option C. Then comes 2, then comes 1, then comes 4. So option C is your right answer. Now, the next question, in the most stable conformation of neomenthol stereochemical orientations. It's very simple. In the case of neomenthol, you have OH, isopropyl and methyl, in which the OH group will be axial and all other isopropyl and methyl will be equatorial. So option B is your right answer. Now coming to the next one, the absolute configuration of the chiral centers of the starting ketone in the following reaction. Here you are given a lithium aluminum hydride reduction and it is given the product as S. And look at this. This is again Cramp's rule. Following Cramp's rule here, the H minus will attack this carbonyl group from the plane which is opposite to that of this plane, carbonyl plane, and it is given as S. So the starting material will be R because here it is opposite, so it will be R. So here the 3 will be R configuration, right? 3 will be R configuration, and now out of which you need to select this carbon is S or R. It's very simple thing to do based on atomic number rule, and out of which it will be S configuration because here this carbon gets the highest priority, then the ethyl group, then methyl group, so it will be anti-clockwise S. So 43, A is your answer. So these are the questions that we are stopping here. In the next class we will discuss some more questions based on this conformations, aromaticity and stereochemistry. So that's all for now. Please do watch this video and subscribe it. Okay, thank you all. Thank you.